Okay, today I want to look at the Taylor series. So the Taylor series, the Taylor series is denoted by summation of n equals to 0 to infinity n series for n into x minus center, which is c plus n over the n factorial. So this is our overall formula for the Taylor series. So anytime you are given a Taylor series, it has to be represented in this format after calculations. Yes, this is the format that you have to represent your Taylor series in. So let us look at an example. Example 1. Find the Taylor series. Find the Taylor series of f of x equals to a exponential centered at c equals to 3. So first of all, we have to list the derivatives of e exponential from 1 to any number you can, since it runs to infinity. So for me, I'll do it up to the fifth derivative. So f equal to that first derivative of that remains to be this according to the rules of derivation, as that is calculus 1. You will get that. So f, the second derivative of this one, equals to e raised to power x. The third derivative of that remains to be that, so it will just be equal up to infinity. So we can decide to replace x by the center 3, and now everything that is x will change to 3. So this one, e will be e raised to power 3. So first derivative of that will be e raised to power 3. Second will be e raised to power 3. So it runs up to infinity. Raised to up to, remember it goes up to infinity. So just write that. But not for all will be equal, but uh, since we are dealing with the e exponential, yes, they have to be equal up to down. So we can decide to list the values of the series, the numbers in the series. Yes, we can decide to list them. And here we're gonna start. So f of x will be when n is equals to 0. So f of x will be just that. Yeah. Plus when n is equals to 1, when n is equals to 1, raised to power 1. Remember, we are dealing with the Taylor series, so you just look a format from the formula up there. So that is what I'm writing down here. So raised to power 1 factorial equals ds x minus c raised to power 2 over 2 factorial. So this goes up to infinity. So we can decide to replace f of x with the e, the e that we are dealing with. So this is what the question wants. So we have to deal with it. So e raised to power x, the Taylor of e raised to power x now, the Taylor series will be represented in this form. So remember, we replaced this one with this one. So we'll start with e raised to power 3, that is when n is equals to 0, plus when n is equals to 1, it will be e raised to power 3 into x minus 3, since remember c is 3, into x minus 3 raised to power 1 over 1 factorial, plus f, or not f, remember, I'm sorry, e raised to power 3, we already replaced it, e raised to power 3 into x minus c raised to power 2 over 2 factorial. So this goes up to infinity. Yes, this goes up to infinity. So we can decide to write the overall Taylor series of Ex. So we can reflect our answer from up here. This is the format that n is equals to 0 up to infinity. But now remember, this one is the overall Taylor series of E exponential. So n is equals to 0 up to infinity over. So we look at the common things. What is common? So if you see n series for n in this series here, you can see it is common. Here it is common. Here it's there. It's there. So we'll include it in the overall formula. So it is common. This one also runs across. If you continue writing the series, you'll find that this one runs across. So it will also include it here. And now let us go to the powers. You can see the powers is from 1, 2, the next will be power 3, then the other one power 4, which means it varies, it is a variable. So we'll just denote it with the n, since it's a variable. And then now the factorials also vary according to the power. So it will be n factorial. Because also if you see the coefficient of the factorial and the power, they are almost the same value. If it's 1, it's 1, 2, 2. So n, we use n up here and n down here. So this one is the overall formula of the Taylor series of E exponential. Thank you for that.